Level up your listening with Bose Quiet Comfort Ultra earbuds and headphones with immersive sound and world-class noise cancellation for a not-so-silent night. Visit Bose.com/Spotify to shop sound that's more than a present.
Gear Patrol calls their new dive watch the best sub-$500 dive watch. Full stop. Men's Health rated them as the most stylish solar watch in the game. Who are we talking about? It's Movement. They're leveling up your gift giving with the sleekest watches you can buy and the biggest deals of the season. Shop 30 to 50% off Movement's innovative California clean watches, jewelry, and accessories with fast free shipping and returns now at mvmt.com. That's mvmt.com.
This is SpaceTime, Series 24, Episode 90, for broadcast on the 6th of August 2021. Coming up on SpaceTime, Ingenuity scopes out the road ahead on Mars, dark matter slowing the spin of the Milky Way's central bar, and new observations testing the standard model of particle physics. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists studying NASA's Mars Ingenuity helicopter's ninth flight have revealed a spectacular landscape of dunes and ancient rocky outcrops spread across the dried river delta and lakebed of Jezero Crater. The images provide mission managers with an unprecedented opportunity to scout out the road ahead for the Perseverance rover as it explores the surface of the red planet in search of signs of life. Ingenuity's provided new insights into where different rock layers begin and end. The flights also revealed obstacles that the six-wheeled Perseverance rover will need to drive around as it explores its alien environment. During the flight, designed to test the helicopter's ability to serve as an aerial scout, Ingenuity soared over a dune field nicknamed Ceta. Perseverance is targeting a raised ridge region beyond Ceta, but following Ingenuity's aerial observations, the car-sized rover will detour south around the dunes, which will be too risky to cross. Getting bogged in sand is what ended the journey for the Mars exploration rover Spirit back in 2009, 5 years after it landed in Gusev Crater. The colour images taken by Ingenuity from an altitude of 10 metres offer the rover team far greater detail than they could hope to get from orbital images typically used for route planning. While the cameras aboard NASA's Mars Reconnaissance Orbiter can resolve rocks down to about a metre in size, mission managers usually rely on rover images to see smaller rocks or terrain features. Perseverance Deputy Project Scientist Ken Williford from NASA's Jet Propulsion Laboratory in Pasadena, California, says once the rover gets close enough to a location, mission managers are forced to move to ground-scale images and compare those with the orbital ones. And that's where Ingenuity comes in. It provides intermediate-scale imagery that nicely fills the gap in resolution. This is SpaceTime. Still to come, dark matter slowing the spin of the Milky Way's central bar, and new observations testing the standard model of particle physics. All that and more still to come on SpaceTime.
Level up your listening with Bose Quiet Comfort Ultra earbuds and headphones with immersive sound and world-class noise cancellation for a not-so-silent night. Visit Bose.com/Spotify to shop sound that's more than a present.
A new study claims the rotation of the Milky Way's galactic bulge has slowed by about a quarter since its formation due to dark matter. The Milky Way's galactic bulge is a densely packed bar-shaped region of stars at the centre of the galaxy, out of which the galaxy's spiral arms extend. The discovery, reported in the monthly notices of the Royal Astronomical Society, vindicates predictions of a slowdown first made more than 30 years ago. The findings are based on observations by the European Space Agency's Gaia mission. It was looking at a large group of stars known as the Hercules stream, which are in resonance with the central bar, revolving around the galaxy at the same rate as the bar's spin. The Hercules stream stars are gravitationally trapped by the spinning bar. The study's authors say the discovery provides new insights into the nature of dark matter, which acts like a counterweight slowing galactic spin. Scientists have no idea what dark matter actually is, even though they know it makes up around 80% of all the matter in the universe. They know dark matter exists even though it's invisible because they can see its gravitational interaction with normal matter. If the Milky Way's central bar's spin slows down, then the stars in the Hercules stream would move further out in the galaxy in order to keep their orbital period matched to the bar's spin. Stars in the Hercules stream can be identified by their higher metallicity, that is, they're richer in elements heavier than hydrogen and helium. And that proves they've travelled away from the galactic centre, where stars and star-forming gas are about 10 times as rich in metals compared to stars in the outer galaxy. Using this data, the authors inferred that the bar, which is made up of billions of stars and trillions of solar masses, has slowed down its spin rate by at least 24% since it first formed. One of the study's authors, Ralph Shawnrich from University College London, says the counterweight slowing this spin must be dark matter. Until now, astronomers have only been able to infer dark matter by mapping the gravitational potential of galaxies and subtracting the contribution of visible matter. These new findings provide a new type of measurement of dark matter, not of its gravitational energy, but of its inertial mass, that is, the dynamical response which is slowing the bar's spin. See, different models for dark matter will show different changes in the inertial pull on the galactic bar. This is SpaceTime. Still to come, new observations test the standard model of particle physics, and coming up on August Skywatch, we look at the red supergiant Antares, Barnard star, which is the second nearest star system to the Sun, and we check out the annual Perseids meteor shower. All that and more still to come on SpaceTime. Scientists with the world's largest atom smasher, the Large Hadron Collider at CERN, have observed the simultaneous creation of 3 massive W bosons for the first time. W bosons are subatomic force particles which carry the weak nuclear force. This is the force underlying some forms of radioactivity, governing the decay of unstable subatomic particles such as mesons, and initiating the nuclear fusion reactions found in the Sun. The discovery of this rare process creating triple W bosons allows researchers to make precise measurements testing the standard model of particle physics, the foundation stone of science's understanding of the universe. The findings by the ATLAS collaboration are based on an analysis of data from the full Large Hadron Collider Run-2 dataset recorded by the cathedral-sized ATLAS detector between 2015 and 2018. In order to make their findings, physicists analysed some 20 billion high-energy proton-proton collision events recorded and pre-filtered by the ATLAS experiment, looking for just a few hundred events expected from the triple W process. These events were buried in almost 5 times more background events, which just happened to mimic the signal signature. See, the thing is, as one of the heaviest known elementary particles, the W boson's able to decay in several different ways. ATLAS physicists focused their search on the 4 decay modes with the best discovery potential due to their reduced number of background events. In 3 of these modes, 2 W bosons decay into neutrinos and into electrons or muons carrying the same positive or negative charge, while the 3rd W boson decays into a pair of light quarks. In the 4th decay mode, all 3 W bosons decay into a charged lepton and neutrino. To pick out the WWW signal from the large number of background events, researchers utilised a machine learning technique called boosted decision trees in order to identify specific signals and spotting small but key differences between variables. They observed the process with a statistical significance of 8.2 standard deviations, well above the 5 standard deviations or 5 sigma threshold needed to declare an observation. This detection allows physicists to look for hints of new interactions in particles that might exist out there beyond the current energy reach of the Large Hadron Collider. The Large Hadron Collider at CERN, the European Organisation for Nuclear Research, is a 27-kilometre long ring buried 100 metres beneath the Franco-Swiss border near Geneva. Part of a large complex of particle accelerators, synchrotrons and other high-energy laboratories, the L8C includes 4 massive detectors called Atlas, Alice, CMS and L8CB, each located in one of 4 massive underground caverns. Packets of protons or other subatomic particles are accelerated to within 99.9999% the speed of light in opposite directions in 2 particle beamlines around the ring, guided by cryogenically cooled superconducting magnets. The beamlines can intersect at any of the 4 detectors, colliding the particle packets and creating the sorts of conditions, pressures and temperatures that would have occurred just after the Big Bang 13.82 billion years ago. This is SpaceTime.
Littleton Coin Company is ringing in the holiday season with daily deals. Visit littletoncoin.com for at least 15% off select products now through November 28th. Save on your favorite coins, such as Morgan Silver Dollars, Kennedy Half Dollars, commemorative quarters, and much more. But hurry, each day offers a new deal you don't want to miss. Visit us now at littletoncoin.com. That's littletoncoin.com. Littleton Coin Company, serving collectors since 1945.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
And time now to turn our eyes to the skies and check out the celestial sphere for August on SkyWatch. August is the 8th month of the year in the Julian and Gregorian calendars. It was originally named Sextilis in Latin because it was the 6th month of the original 10-month Roman calendar under Romulus in 753 BCE when the year started in March. It only became the 8th month when January and February were added to the start of the year. In the year 8 BCE, it was renamed in honor of the Roman statesman and military leader Augustus, who had achieved several military victories, including the conquest of Egypt during the month. Okay, turning to the heavens, and the constellation Scorpius the Scorpion is high overhead this time of year, covering almost a third of the August night skies. At the heart of Scorpius, located some 470 light-years away, is the red supergiant Antares. A light-year is a distance of about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Red supergiants have the largest diameters of any known star. They evolve out of main sequence stars with more than 8 times the mass of the Sun. A main sequence star is a star fusing hydrogen into helium in its core. When stars stop fusing hydrogen into helium in their core, the balancing act between gravity pushing a star's mass down towards the centre and energy from nuclear fusion in the core pushing outwards ceases, and gravity wins, causing the star to begin to collapse inwards, crushing the stellar core until the increase in pressures and temperatures trigger helium fusion. At the same time, a shell of hydrogen around the core begins to fuse, causing the star's outer gaseous envelope to expand out into a bloated giant. And now, being further away from the core, the stellar surface starts to cool down, becoming redder in colour. While Sun-like stars will become red giants, those that are far bigger, 8 times or more the mass of the Sun, become red supergiants. Supergiants will fuse all their core helium into carbon and oxygen within just a few million years. They'll then begin fusing this core carbon and oxygen into progressively heavier and heavier elements until they eventually begin to produce iron in their core. Now, no star, no matter how massive it is big enough to fuse iron into heavier elements. And so then the star will collapse catastrophically in what's known as a core collapse supernova, an explosion bright enough to outshine an entire galaxy. The end result of this core collapse supernova will be the creation of either a neutron star or a black hole, depending on the progenitor star's mass. The name Antares means rival of Mars, and indeed when they're close together in the sky, they do look very similar. Antares, or Alpha Scorpii as it's sometimes called, has some 12.4 times the mass and an incredible 450 times the diameter of our Sun, and is one of the largest known stars in the universe. Antares is so big that were it placed where the Sun is at the centre of our solar system, it would engulf all the inner planets, Mercury, Venus, Earth and Mars. Its outer surface would reach almost as far as the orbit of Jupiter. Antares is a binary system. There's a companion star orbiting with it called Antares B, a massive spectral type E blue-white star, at least 7.2 times the mass and 5.2 times the radius of the Sun. It's located about 224 astronomical units beyond the primary star. An astronomical unit is the average distance between the Sun and the Earth, about 150 million kilometres or 8.3 light minutes. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're closely followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in, spectral type K orange stars, and the coolest and least massive of all stars are spectral type M red stars, commonly referred to as red dwarfs. Now, each spectral classification is further subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now, put all that together, and our Sun is a spectral type G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types LT and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red dwarf stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or 0.08 solar masses. Located near Antares is the spectacular globular cluster Messier 4, or M4 for short. Named after the 18th century French astronomer and comet hunter Charles Messier, it's one of a catalogue of 103 fuzzy objects which weren't comets, and so were of no interest to Messier, and so he made a list of them, so he didn't waste his time looking at them. Other astronomers have since added further celestial objects to the catalogue, bringing the total to around 110. Located some 7,000 light-years away, Messier 4 can be seen through a pair of binoculars, making it one of the closest globular clusters to Earth. Globular clusters are densely packed spheres containing thousands to millions of gravitationally bound stars, which it's thought were either originally all born at the same time in the same stellar nursery, or are the surviving cores of galaxies that have been cannibalized by larger galaxies. They're almost always found orbiting the halo of galaxies. The Milky Way has about 150 of them, and they're all usually very ancient, some dating back to around 12 billion years. Located just below the sting of Scorpius are two open star clusters, M6 and M7. M7's the nearer of the two, located about 800 light-years away, while M6 is a more distant 2,000 light-years. Open clusters are less densely packed than their globular cluster counterparts, with the stars inside them less gravitationally bound and more prone to drifting away over time. Another open star cluster in Scorpius is NGC 6231, located about 6,500 light-years away, just near the star Zeta Scorpii. NGC 6231 is a bright open star cluster containing around 120 stars, including a significant population of highly luminous supergiants, numerous white-yellow stars, and at least 2 Wolf-Rayet stars. Wolf-Rayettes are extremely luminous evolved stars reaching the ends of their lives. Having run out of hydrogen for core fusion, they're no longer on the main sequence and are instead fusing progressively heavier and heavier elements in their cores. This causes them to have surface temperatures of up to 200,000 degrees Celsius, and such extreme temperatures generate powerful stellar winds. Just behind Scorpius is the constellation Sagittarius, the half-man, half-horse of Greek mythology. And as we mentioned in last month's Skywatch, the centre of the Milky Way galaxy is found in Sagittarius, roughly 27,000 light-years away. The name Sagittarius can be traced back beyond the Greeks to the ancient Mesopotamian archer god Nergal. Sagittarius is known for its many nebulae and clusters, more than any other constellation. One of the largest and brightest is the globular cluster M22, big enough to be visible to the unaided eye. Located about 10,600 light-years away near the galactic bulge, M22 is more elliptical than most globular clusters. It's located just south of the ecliptic, the plane in the sky upon which all the planets orbit the Sun, and it contains over 70,000 stars, covering an area of around 100 light-years. It also contains at least 2 black holes, and is one of only a handful of globular clusters known to contain planetary nebulae, the puffed-off outer gaseous envelopes of dead Sun-like stars. Located in the sky next to Scorpius in the west and Sagittarius in the east is the constellation Ophiuchus, the healer or serpent-bearer, often portrayed as a snake coiled around a man. In Greek mythology, Ophiuchus raises Orion from the dead after he was bitten by Scorpius. Ophiuchus contains several star clusters and other interesting features, including Barnard star. Barnard star is the second nearest star system to the Sun, beaten only by the Alpha Centauri triple star system. Located some 5.9 light-years away, Barnard star is a spectral type M red dwarf, about 0.144 times the mass of the Sun. Our Sun is around 4.6 billion years old. At between 7 and 12 billion years of age, Barnard star is considerably older than the Sun and may be among the oldest stars in the Milky Way galaxy. It's lost a great deal of rotational energy, and its periodic slight changes in brightness indicate that it's rotating about once every 130 days. By comparison, our Sun rotates roughly once every 29 days. Given its age, Barnard star was long assumed to be quiescent in terms of stellar activity. But in 1998, astronomers observed an intense stellar flare, indicating that Barnard star is indeed a flare star. Flare stars are variable stars that can undergo unpredictable dramatic increases in brightness lasting a few minutes. It's believed that the flares of flare stars are analogous to solar flares in the Sun, in that they're generated by stellar magnetic energy stored in the star's atmosphere. Lying just to the west of the Scorpion is the constellation Libra, the Scales. In Greek mythology, Libra represents the claws of Scorpius the Scorpion. However, the Romans considered Libra a distinct separate constellation from Scorpius and thought them to be the scales symbolizing the equinoxes, the times of the year in March and September when the Earth gets equal lengths of day and night. That's because 2,000 years ago, when all this was made up, the Sun moved into Libra at the time of the September equinox. But due to precession, as the Earth's spin axis wobbles in direction, this point in time has now moved into the adjoining constellation of Virgo. If you look to the south in the Southern Cross, that's the constellation Centaurus, another half-man, half-horse mythical beast. Centaurus was the teacher of many of the Greek gods and heroes. He was placed among the stars in the heavens after accidentally being killed by a poisoned arrow fired by Hercules. Close to the pointer star nearest the Southern Cross, Beta Centauri, lies NGC 5139, Omega Centauri, the largest and brightest globular cluster in the visible sky. Because of its brightness, the ancient Greek mathematician and astronomer Claudius Ptolemy originally thought Omega Centauri was a star. It has a diameter of more than 150 light-years and contains an estimated 10 million stars, giving it some 4 million times the mass of our Sun. Located some 15,800 light-years away, Omega Centauri is another very ancient globular cluster, around 12 billion years old, and it contains many so-called population 2 stars. These are the second generation of stars to have formed, and were created directly out of the remains of the very first stars in the universe. Stars in the core of Omega Centauri are so crowded, they're estimated to average only 0.1 light-years away from each other. And that compares to the nearest star to our Sun, Proxima Centauri, which is some 4.2 light-years distant. Located close to Omega Centauri in the sky is the giant lenticular galaxy NGC 5128 Centaurus A, which we see looking like it's split in half by a thick band of dust. The galaxy was discovered in 1826 by astronomer James Dunlop from his home in what is now the Sydney suburb of Parramatta, a time long before the bright lights of a modern city would make such a discovery impossible. Located some 13 million light-years away, Centaurus A is one of the strongest radio sources in the sky and is thought to be the result of a merger between an elliptical and a spiral galaxy. It can be easily seen using a pair of binoculars, but you'll need a telescope to make out its spectacular dust lanes. August is also the time of the peak of the annual Perseids meteor shower. The meteors are the debris trail ejected by the comet Swift-Tuttle as it travels along its 133-year orbit through the solar system. As its name suggests, the Perseids radiant, that is the point in the sky from which the meteors appear to originate, lies in the constellation of Perseus. The Perseids are one of the oldest known meteor showers, with early Chinese historical records of its activity going back almost 2,000 years. They're active between July the 17th and August the 24th, with a peak on August 12th with around 60 meteors an hour being visible. The Perseids are very bright and fast-moving meteors, travelling at speeds of 59 kilometres per second. They're best seen between midnight and just before dawn, producing long, bright trails and some fireballs. Most Perseids burn up in the atmosphere at altitudes of over 80 kilometres. They're best seen from the northern hemisphere, so for southern hemisphere sky watchers, look to the north with the radiant below the northern horizon. And now, with a look at the rest of the August night skies, here's Jonathan Nally, the editor of Australian Sky and Telescope magazine.
For us down here in Australia where I am, temperate latitudes down the south, it's still our winter here. It's the last month of winter. So our winter, for Australia we go June, July, August is our winter, right? So this is the last month of winter. And then the springtime comes and gets more disturbed sort of weather, and weather gets worse. Actually pretty nice during winter in where I live, clear skies and everything, so that's pretty good. I'm pretty lucky in that respect. So it means during August we still got some really nice skies, really nice night skies, and it's still dark for quite a long time. The hours of darkness haven't shrunk too much yet, and the hours of daylight aren't creeping up too much just yet. When we get into September, it'll be different, of course. So if you go outside in the mid-evening during August, this part of the world, you look up, you'll see the Milky Way stretching right across the sky from the northeast down to the southwest. And for us down here, we're really lucky because this time of year we've got the centre of the Milky Way pretty much directly overhead from sort of middle latitudes down south, and that stacks of really good stuff to see in there if you're a stargazer. And professional astronomers really like it too, because there are lots of really interesting things to see in the direction of the centre of our galaxy, because we're looking through more of our galaxy. What is it, about 30,000 light years or something we're looking through between here and the centre of our galaxy, roughly. If we look in the other direction, we're looking out to the outskirts of the galaxy. There's less there. And if we look up or down out of the galaxy, we're just looking through a very thin part of the galaxy, because the galaxy is sort of discus-shaped. And so we're about two-thirds of the way out from the centre of the discus. So there's not much to see going out of the discus straight up or straight down or out towards the edge, but looking into the middle of the discus where it's all thick and thicker and lots more stuff, you can see lots of good stuff, and including, of course, the black hole that's at the centre of our galaxy. Professional astronomers are really interested in that because it's the nearest big black hole we can get our hands on, but the nearest big one that we can see, the nearest big one we can study, and it's the nearest galactic centre that we can study too. So we're pretty lucky in that respect. Down in the south, from where I'm looking, we've got the Southern Cross in the sort of southwestern part of the sky. Now, it's now no longer standing upright in the early part of the evening. It's laying on its right-hand side, about halfway up from the horizon. The Southern Cross itself is located within the band of the Milky Way, and stretching northward from it along the Milky Way are lots of other famous and interesting constellations. You've got Centaurus, you've got Scorpius, Sagittarius, and constellation Scutum. Down in the south, down towards the horizon down the south, you've got the famous Magellanic Clouds. These are these two large-ish galaxies that are nearby to the Milky Way. They're the nearest large-ish galaxies. They're sort of oddball galaxies, but they're still reasonable size, and you can see them with the naked eye. If you've got dark skies and you've let your eyes get adapted to the dark, they just look like fuzzy clouds in the sky. But when you look at them and you think, wow, that's actually a galaxy I'm seeing, that is pretty spectacular. I mentioned that constellation Scutum a moment ago, but what the name Scutum stands for and what it is?
Something to do with riding a Vespa?
No, actually not. Oh, very good. It's actually named after an Italian scooter. You're right in that respect, a scooter.
Oh, really?
Yeah, but SCUTA. This scooter is not a scooter that you ride on. The scooter SCUTA means shield. It's an ancient Roman shield.
Ah.
So that's what it is. So Scutum is the constellation of the shield. Okay. Now, if you're out there stargazing for long enough, now I said that at the middle, when you go out in the early part of the evening, you'll find the Milky Way stretching from northeast down to the southwest. But if you leave it long enough, the Earth will have turned on its axis. If you go out again and you have a look, you'll find that the Milky Way has shifted to the north and the west, and it's getting lower and lower in the sky until about 4 a.m. It's disappeared. You actually really don't see the Milky Way because it's really circling us around the horizon, just from our point of view now that the Earth has turned. So you've got all this rest of the sky nice and high above you. So Sagittarius, for instance, has sort of disappeared from view largely, and Scorpius and those sort of ones. Best time to see those is to go out in the early evening. Now to the planets. Jupiter and Saturn are the stars of the show this month, no pun intended, because they're not stars, of course. Both of them will be reaching opposition in August, okay? Now, opposition is when an outer planet, you've got Jupiter, Saturn, Uranus, or Neptune, or in this case, Jupiter and Saturn, is when an outer planet and the Sun are in opposite directions in the sky as seen from the Earth. Big deal, you might say, who cares? Well, it is a big deal if you like looking at planets, because when a planet's at opposition, you'll find that the planet is rising in the east as the Sun is going down in the west. And that means that because it's rising in the east at sunset, it'll be visible for more or less 12 hours, all the hours of darkness. So as the Earth turns on its axis, that planet will rise in the sky and it will then start to set in the sky in the west. And as it's setting in the west in the morning, the Sun will be coming up in the east in the morning. So opposition means the planet's going to be visible all night long. And that is good. So, for instance, if you go out in the middle of the evening and think, I'm going to have a look at Jupiter, and you go outside and you think, there's clouds, I can't see Jupiter. Well, you can get up in the morning and have a look at it instead, or vice versa. So you've got all that time to see the planet, because very often with planets, they might set an hour or two after sunset, so you've only got a short time to look at them. And the other good thing about opposition too, and the ability to see planets all night long, is that you get the best viewing of a planet when it's up high in the sky, which will be, in the case of an opposition, at midnight, when the planet is highest. As the Earth is turned, the planet will rise up from the east and get higher and higher and higher in the sky. Because when it's higher in the sky, you're looking through less air, less of the Earth's atmosphere, so you don't have all the murk and the muck and the smog and all that sort of thing, and you don't also get the twinkling effect caused by air currents in the Earth's atmosphere that you get when you're looking directly at the horizon, for instance, if the planet's very low down. You still get a bit of twinkling up in the upper atmosphere if you're looking when the planet's high up, but not as much as you would get when the planet's down towards the horizon. In fact, there have been UFO reports, for instance, when Venus is very low on the horizon, because Venus is very bright. And when it's low down, and if there's a lot of air currents between you and the planet when you're looking at it when it's low down, then Venus can actually appear to change colour. It can be white and red and green, and be doing all sorts of funny things. It's just the refraction through the Earth's atmosphere. And people ring up and say, I've seen a UFO, it's changing colours. Can't possibly be a planet or a star or an aeroplane, whatever, because it's changing colours. Well, that can happen. So anyway, opposition's a really good time to see the outer planets. As for the other planets at the moment, or Mars, it's really low down on the western horizon after sunset. Might be a little bit difficult to see if you don't have a clear horizon. By that I mean if there are trees or houses or hills and things in the way, but if you can get up high, or if you've got a clear horizon, then you should be able to see Mars, a little red dot in the western sky after sunset, but it's going to get lower and lower as each day passes, and by the end of the month it's going to be pretty much out of view in the glare of the sunset. But nice and bright and climbing higher in the sky as each day goes past will be Venus, also out in the west after sunset. You simply cannot miss Venus because it's so big and bright, and it will get nice and bigger and brighter as the days goes on because, as I say, it's getting higher and higher. And the other planet that you can see with the naked eye is Mercury. Same direction, look in the same direction as Venus, but Mercury will be lower down, just above the western horizon after the sun has set. It looks like a little white star, but it's actually a planet, of course. It'll be climbing a little bit higher and higher, so the second half of the month will be the best time to see Mercury.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.